So we've talked briefly about the XY plane. We know that this is the Y coordinate and this is the X coordinate. You can plot points on a graph. Very important. Graphing is one of the most important tools that you use in all of mathematics. So now let's quickly talk about something that is very important, which is knowing about parallel and perpendicular lines. In our Tyler Wallace algebra text, if you go to 2.5, it actually focuses on this concept of parallel and perpendicular lines, right? Sorry, I wrote 2 R's there, parallel and perpendicular lines. So imagine if I give you 2 lines, right? If I tell you that the equation of a line was y is equal to 2x plus 6, and then I tell you the equation of the other line is y is equal to 2x plus 10, there is a certain thing you need to know about lines that are parallel. That means lines that will never meet, right? And this is just a sketch of 2 random lines. If lines are parallel, that means the slope of the first line will equal the slope of the second line. Their slopes will be equal. So I've mentioned the slope-intercept form. It's one of the most important things to keep in mind with graphs, the slope-intercept form. So y is equal to mx plus b. M is your slope and b is your y-intercept. So the slope-intercept form tells you what will happen when you basically have, again, you have a slope and you have the y-intercept, and you can use that to graph. I actually recommend that as the quickest way to plot a graph if you had to, if you don't have to show table of values. Now, using a table of values is important, and there's a video that has that discussion. But if you just need to graph or sketch a line quickly, the slope-intercept form works very well. So if you have 2 lines, let's say I gave you a line as x plus 10 is equal to, actually no, if I gave you x plus 10y is equal to 20, and you had to actually switch this to the slope-intercept form, basically you solve for y. That is the slope-intercept form. You solve for y. And so when you solve for y, you have it in the slope-intercept form, right? So we have the slope-intercept form. We know that when 2 lines are parallel, that their slopes are equal. Think about 2 people driving to a certain city. If one person leaves 50 minutes before the other person, but they go the exact same speed, they will never meet except they get, one gets to the destination and then the other one will meet them there. But you see that when you're traveling with the same slope, right, or with the same rate of change, that's what the slope is here, distance over time, that it will result in people not being able to meet. So when 2 slopes are the same, then those lines don't meet, and we just say that they're parallel. So if I give you 2 lines and I say, are these parallel? Just check their slopes. What about perpendicular? If we say perpendicular, that means that the slope of the one line and the slope of the other line will form an angle 90 degrees. That means the slope of one is equal to the negative reciprocal of the slope of the other one, right? And I can write it in either way. So the slope of one is equal to the negative reciprocal of the other one. The other way you can think of it is if you multiply their slopes together, you get a negative 1, right? So if you multiply their slopes together, you get a negative 1. So perpendicular lines will form an angle 90 degrees, right? That's their relationship there. Perpendicular lines form an angle 90 degrees. The negative reciprocal, right? One is the negative reciprocal of the other one. So that's how they work. That's how perpendicular lines work. Okay, so we've talked about parallel lines where their slopes are equal. M1 is equal to M2. And we've talked about perpendicular lines where their slopes, the slope of one times the slope of the other one is equal to negative 1. It is always important to solve and put your equation in the form of y is equal to mx plus b. So y is equal to mx plus b is what you want to do when you're trying to look at what the slope is. So again, if they give you a problem like this, let me write the problem out. So if they tell you y plus 3 over 5x is equal to 4, you can just simply subtract 3 over 5x from both sides, and you get this answer. You've written it in the slope-intercept form. What if I told you to graph this, or to sketch the graph? If you want to sketch the graph, you go to your y-intercept, 1, 2, 3, 4, right? That's your y-intercept. And you look at your slope. In this case, it's negative 3 over 5. So it means that you go down 3 units and over 5 units. Down 3 units and over 5 units. up 3 units and back 5 units. Now, we know that the graph is going to look I'm sorry, this is just a sketch. We know that it's going to look like that. Why? Because it has a negative slope. When you have a negative slope, that means that your graph will tend downward, right? Think of negative is like, oh, not good, going downhill, right? That's like negative. And if you think of a positive slope, something will be going upward, right? That's a positive slope. So we need to know negative and positive slope, right? And so when we have y is equal to mx plus b, that can be used, that information can be used to graph. You sketch starting with the y-intercept, and then you use the slope to find the next set of points. So start with y-intercept, and then use slope to find more points. Use slope to find more points. Do you see? So use your slope to find more points. So that's how we would find the other points, and then we can graph the line that we're trying to graph. So with that knowledge of graphing, right, and there's more examples in our Tyler Wallace chapter 2 text, Tyler Wallace Algebra, a free text PDF. If you want to go deeper into understanding graphing, you can do that. But let me take this time to also say this. There are times where the slope of one will equal the slope of the other. There are times where the slopes of both of them will equal -1. But there are times where neither will occur. And that is okay. You could just say neither. They're neither parallel nor perpendicular. So you don't have to force an answer or solution that isn't there, right? So that's something to keep in mind. Now let's talk about graphing inequalities. Graphing inequalities. So we've talked about graphing lines. Graphing inequalities is pretty much the same thing, except for two things. Number one, if you have y is less than 3x plus 5, for example, then you use these kinds of dashed lines, right? If it was y is less than or equal to 3x plus 5, you will have a solid line. Again, I'm just showing you what kind of line you have. I'm not graphing it yet. And the second exception is you have to shade, okay? So we're going to talk about these two things. When to use a dotted line and when to use a solid line, and the question of shading, okay? Otherwise, the principle is the same. If you have an xy coordinate over here, so you have your y and your x coordinate, and this is the graph, 3x plus 5, so I go to 1, 2, 3, 4, 5, right? That's 5. So that means I'm going to go up 3 and over 1, down 3 and over 1. So that's what my graph will look like, right? If I'm just graphing y is equal to 3x plus 5. I start with the y-intercept, and then I go up 3 and 1 over to the right, right? That's how I find my points. However, if I want to do it with either of these situations, now it's going to be different. So let's try that now. So you have, we're starting at 5 again. 1, 2, 3, 4, 5. We have 5. So you go up 3, 1, 2, 3, and over 1. Down 3 and over 1. Okay, but guess what? Now we use dashed lines. Okay? For this first graph, we use dashed lines or dotted lines. And then guess what? We shade, okay? And if we're going to shade, that means we're going to shade when it's less than, we're going to shade below the graph, okay? If it was greater than, you would be shading above. If this was y is greater than 3x plus 5, you would be shading above. So when it's less than, you're shading below the graph. And when it's greater than, you're shading above the graph. If it was y is less than or equal to 3x plus 5, again, this is just a sketch. And let's say this is the sketch, and this was your 5. You would use a solid line. Do you see? So basically, the graph of y is equal to 3x plus 5, and the graph of y is less than or equal to 3x plus 5, in terms of the line that is drawn, it's a solid line. But you're going to shade. In this case, when it's less than, you shade. So remember, graphing inequalities is the same in the principle of using your y-intercept and then using your slope to find the other points. But you will end up shading. The other difference is that you might have to use a dotted line if it's y is less than or y is greater than, which is different from y is less than or equal to or y is greater than or equal to. If you have questions on graphing inequalities or any aspect of it, let me know. It's always important to isolate what specifically your question is about, and then we can go from there. Otherwise, remember, graphing is the same principle. Use the slope, use the y-intercept, and you'll be good to go. So let's end with the distance and midpoint formula. Distance and midpoint formula. So with the distance formula, we basically know that it is d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And the midpoint formula is x1 plus x2 over 2 and y1 plus y2 over 2. Now, keep in mind, you can derive these formulas if you forget. But these are just the formulas. You can use the Pythagoras theorem to derive the distance formula, for example. So if I give you points 5, 10, and 10, 20, right? And you're supposed to find both the distance formula and the midpoint. Find the distance and the midpoint of those 2 points. For the distance formula, we just go here. We say x1, y1, x2, y2. The same way you found the slope. You label x1, y1 and x2, y2. You cannot label x1, y2 and x2, y1, for example. They have to be together. The ones have to be together and the twos have to be together. If you prefer to call this x2, y2 and call this x1, y1, that's okay. But you cannot. You just have to be careful in how you flip those values. So x1, y1 have to be together, or you can call it x2, y2 together, and the same thing goes here. But let's say I call this my x1, y1 and this my x2, y2. That will become, so if this is x2, y2, so that's 10 minus 5 squared plus, and then 20 minus 10 squared. So that's d is equal to the square root of, we have 5 squared, which is 25, plus 10 squared, which is 100, right? And I can just write that as 100. So that's 100. So then d is equal to the square root of 125. By the way, you need to remember how to simplify your radicals. This 125 is the same thing as 25 times 5, right? So it's 5 square root of 5. If you don't remember how to simplify the radicals, I highly recommend going to a video on radical simplification, or just email me and say radical simplification and we'll send you a resource on that. And then, so basically that's the answer to the distance. The distance is 5 square root of 5. Generally, we don't need it in decimal. You can leave it as 5 square root of 5. Over here, we would have the midpoint, which is equal to, you have x1 plus x2. So you have 5 plus 10 over 2. And then you have 10 plus 20 over 2. So you have 15 over 2, comma 30 over 2. So 7.5 slash 15 or comma 15. That's the midpoint, right? You do x1 plus x2 over 2 and y1 plus y2 over 2. And that gives you the midpoint for the problem in question. Let me know if you have any questions on midpoint formula or distance formula. Otherwise, have a wonderful day.